Hello students, welcome to my channel. My name is Darshan, I am your maths prof. So this is the fourth session of your first chapter number system, and in this session we'll be covering the most important, the most crucial topic of this chapter, that is indices. And this is the same topic which will be covered in second chapter also, where we will apply this indices to algebraic terms also. So make sure you learn this very deeply, and I'll request you to revise this topic as much as you can, because in every paper 2 and paper 4 you'll always find 2 to 3 questions every year. Okay, and in this session I'll give you tips also, extra tips basically, for solving two very commonly asked indices questions. Okay, so let's see some laws of indices first. uh, let's see. Yeah, so a raised to 0, anything raised to, a is any number or any algebraic term. If anything raised to 0 is given, it's always equal to 1. Fine. And then comes the power's power. If it is number a is given, its power is n and the whole power is m, so that both the powers are multiplied with each other, so it will become a to the power n times m. Okay. Third is, whenever there is a multiplication of two terms and both have the same base, power might be different, might be same, but if the bases are same, in that case you can just add the powers. Okay. Acha, make sure you don't make this mistake. This is the very common mistake. I find every year students make these kind of mistakes, that if it is given a raised to n plus a raised to m, so if there is an addition and the bases are same, then what do? They do a raised to n plus m, they add the powers. But this is completely wrong. There is no indices rule for addition or subtraction. Okay, let's see now next, that is a to the power n divided by a to the power m. So same like multiplication, in division also, if the bases are same, both have the same base a, power might be different or same, but if the bases are same, and in division we subtract the power, so that is a raised to n minus m. Here also some common mistake people make, that a raised to n minus a raised to m, they make it a raised to n minus m, which is completely wrong. Okay, I again telling you that there is no rule of indices for addition or subtraction. It's always for multiplication and division. Next rule is for again multiplication only, that a into b whole to the power n. If there is a power of more than one number or more than one variable, the common power is there, then you can separate power, you can give them separate powers, but only when the given numbers or given terms are in multiplication. Again same mistake they make, so I'm enlisting the common mistakes also here, so you don't make that mistake, that if it is given a plus b whole to the power n, students write it like this, a raised to n plus b raised to n, they give them separate power in addition also, which is completely wrong, so it is not equal. Fine. In division also, if you have a common power to two numbers with this division, then you can give them separate power, so it is a raised to n divided by b raised to n. Same, they make mistake in the they apply the same rule for subtraction, that a minus b whole raised to n, they call it a raised to n minus b raised to n, which is wrong. Okay, so I'm making box here, that you don't make the mistakes. Keep this in mind, they are not same. There is no rule of indices for addition or subtraction. It's quite funny that laws of indices are very biased to multiplication and division. There is no rule for addition or subtraction. Then if the power is negative, a raised to negative n, to make it positive, you can reciprocate the base. So base is a right now, so you can make it 1 upon a to the power n. I just reciprocated the base. Okay, here also what the student make mistake, if a raised to negative n is given, what do? They keep the base as it is and reciprocate the power, which is completely wrong. Okay, you never reciprocate the power, it's always the reciprocal of base, है ना? Then square root is basically power 1 by 2. It's a fractional power, it's 1 by 2 power. Cube root is power 1 by 3. Similarly, fourth root is power 1 by 4. So basically, if nth root is given, n could be 2, 3, 4, so square root, cube root, fourth root, fifth root, nth root is given, then you can convert it into the power in the indices like 1 upon n index, a to the power 1 by n. Okay, I hope it's clear now. All the rules are specified here. Now we'll use these rules to solve some questions. Okay, so it's the questions are basically either simplifying the given expression in the indices or solving the equation. So let's see some very simple kind of simplification. Here you can use the laws very easily. You can directly apply the rules and you get the answer in 1 or 2 steps. These will be hardly 1 or 2 mark questions. Okay, so these can be solved very easily. Let's see. First of all, if there is a negative power, we can make them positive by applying that identity that a raised to negative n can be written as 1 upon a to the power n. So to make the index positive, what you can do, you can reciprocate the base. So similarly, 7 by x raised to minus 3. So what you can do, you can make x by 7 to the power positive 3. I just reciprocated 7 by x as x by 7. Now because they are in division, you can give them separate powers. I'll write the identity here. A upon b whole raised to n, that is equals to a raised to n upon b raised to n. In exam you don't need to write all these identities, but here I am just writing them for your reference. So that's x raised to 3 upon 7 raised to 3. I give them separate powers. And now x raised to 3 will remain as it is, but 7 raised to 3 can be solved, can be simplified. That 7 raised to 3 is 7 into 7 into 7, which is 343. So this is your final answer. Very easy. 2 indices rules are applied here. Here only second question, here only one rule is applied. You see there is a multiplication and the bases are common. So whenever there is a multiplication with the same base, you add the powers. Okay, so this is the rule I'm here writing. So h raised to 2 plus 5, that is h raised to 7. Simple. Now this is also very simple, same kind of, but it's an equation, by the way. Here you are supposed to find, I forgot to write it, here you are supposed to find p. I'm writing find the value of p. So it's an equation, you are supposed to solve this equation for p, find the value of p. In equation, keep this in mind, I have specified here in red letters that in the equation type questions of indices, both the sides of the equal to sign must have the same base. If the base are not same, we can factorize the base to make them same. We'll see some questions of prime factorization also, but right now here in this question base are a only. You see on left hand side both the bases are a and right hand side also the base is a. So you don't need to do the prime factorization here. We can directly apply the indices rules and solve this. So in division, if the bases are same, what do? You subtract the powers. So that's a raised to 8 minus p, that is equal to a raised to 2. Now because there is an equal to sign here, so that means whatever is there in the left hand side is exactly equal to the right hand side. So on the left hand side the base is a, you can see right hand side base is a. On left hand side the power is 8 minus p, so that must be equal to the power 2 which is on right hand side. Equal to sign means whatever is on left hand side is exactly identical to the right hand side. So bases are same, it's fine, and powers are also same, so 8 minus p must be equal to 2. So using this fact we'll find the value of p. So now to make the p as subject, what will I do? I'll shift this p here, so this minus p will become plus p, and I'll shift this 2 here on the left hand side, so that positive 2 will become minus 2. So 8 minus 2 is equal to p, which gives me p is equal to 6. So we have solved this answer. We'll solve this equation and the answer is p is equal to 6. Okay, so here in the note I have written that in the equation type of question of indices, both the sides of equal to signs must have common base, and if the bases are not common, you make them same by doing prime factorization. We'll see now how to do that. See this question, it's an equation kind of question where on the left hand side the base is 81, 3, and on right hand side it is 9. Okay, they are not equal, and as I said, in the equation kind of question the bases must be equal, and if they are not equal you are supposed to make them equal by doing prime factorization. Okay, so 3 is already prime, so you don't need to do that with it, but 81 is not prime, we'll do the prime factorization of 81, as well as 9 is not prime, we'll do the prime factorization of 9 also. So 81 prime factorization, we have already learned about the prime factorization in the previous sessions. If you don't remember, just check out those videos and you'll get to know about it, and keep practicing about it, because it's also a tool which we'll use in many questions. So 81 is divisible by 3, so you'll get 27. 27 divisible by 3 will get 9. 9 divided by 3 you'll get 3. 3 divided by 3 you can get 1. And similarly 9 is divisible by 3, you'll get 3. 3 divided by 3 you'll get 1. So this 81 can be written as 3 to the power 4, and 9 can be written as 3 to the power 2. So let's replace that. 3 to the power 4 whole power 2, because 81 power 2 is given, divided by 3 to the power t is equal to 3 to the power 2. The motive of doing this is to find the value of t, I mean to solve the equation for t. Now as we already know that power will be multiplied. There's a rule like this: a raised to n to the power m can be written as a raised to nm. This is the index law I'm using here. So 3 raised to 4 into 2, that's 8, divided by 3 raised to t is equal to 3 raised to 2. In division, if the bases are same, you subtract the powers, so that is 3 raised to 8 minus t is equal to 3 raised to 2. So now we have simplified it. On left hand side only one term is there, on right hand side also it is only one term. You'll have to simplify it to single term whenever there is equation type of question in indices. So left hand side single term, right hand side single term, both have the same base 3. Now as I said, in equation equal to signs, left hand side and right hand side both are exactly identical. So that means on left hand side the base is 3, right hand side is also base 3. Left hand side the power is 8 minus t, so that must be equal to the power 2 on right hand side. Let's make t subject. So here it is minus t, it will go here and become plus t, and this 2 which is positive, it will go here and become negative 2. So it will become 8 minus 2 is equal to positive t, which brings the answer as t is equals to 6. Okay, I hope it's clear. We'll see many questions on the indices when we complete all the explanation of this chapter, and we'll solve some questions. Okay, now next kind of very important questions based on the indices are simplification only, but now the powers will be given in fraction. So in that case you can apply this. I've given you this note that if any number has a power in fraction, do prime factorization of the base. Prime factorization of the base. I'll show you how. See here, first of all, 243 and y raised to 10 both have the same common power 3 by 5, and we have one indices rule that whenever there is a common power in multiplication, you can give them separate powers, which I have already enlisted in the laws of indices. So I'm applying first of all that. So 243 to the power 3 by 5 into y raised to 10 to the power 3 by 5. Now this y is already a variable, you cannot prime factorize it, so keep it as it is. But here 243 is a number, and whenever any number has fractional power, to simplify it, you can make it very easy. You just do the prime factorization of the base. So 243's prime factorization can be done like this. 243 is divisible by 3, so if you divide it by 3, you'll get 81. 81 divided by 3, 27. 27 divided by 3, 9. 9 divided by 3, 3. And 3 divided by 3, 1. So it's basically 3 to the power 5. So let's replace this 243 as 3 to the power 5 to the power 3 by 5, and y to the power 10 power 3 by 5. Now we'll use that rule of indices that if there is a raised to n to the power m, power will be multiplied to each other, so that will be a raised to nm. Okay, so let's do that. So this is 3 raised to 5 times 3 by 5 into y raised to 10 times 3 by 5. 5 got cut here, and you'll get 3 raised to 3 into here 5 2s are 10, so it will be y raised to 2 into 3, which is 6. Now just simplify, find the value of 3 raised to 3, which is 27. So 27 y raised to 6 is your final answer. Clear? I hope you're following me on this. There could be many other methods also for solving this, but trust me, if you follow this thumb rule, you will never lose any marks in this kind of questions. So two major problems the students find in indices kind of questions. First is when the powers are in fraction, and second is in equation kind of questions. So I have already specified in equation, both the sides must have same base, and if the bases are not same, you can make them same by prime factorizing. And second is whenever the power is in fraction of the number, then that number must be prime factorized. Clear? Let's see another question based on the same fractional power. First of all, let's give them separate powers. So that's 343 power 2 by 3 into x to the power 9 to the power 2 by 3, because they are in multiplication. In multiplication, you can give them separate powers. Now this 343 is a number, so numbers fractional power, in that case you prime factorize the base. Base is 343, which is divisible by 7. 7 times 49 is 343. 7 times 7 is 49, and 7 times 1 is 7. So let's replace this 343 as 7 raised to 3 to the power 2 by 3 into x raised to 9 to the power 2 by 3. Now power will be multiplied, so 7 raised to 3 times 2 by 3 into x raised to 9 times 2 by 3. 3 got cut here, 3 3s are 9 here, so you got 7 raised to 2 into x raised to 3 into 2, which is x raised to 6. So that's 49 x raised to 6. This is your final answer. I hope it's clear. As I said, this is the most crucial topic of this chapter. Do solve as many questions as you can of this topic, and I'll suggest you that you revise this topic every month till your final exam of IGCSE. If you are in 9th grade right now, then you have the whole 2 years. Give this topic as much time as you can, and after a certain time it will be very easy for you to solve these kind of questions. If you are in 8th grade right now, you have a lot of time, and I would say if you have 3 years, then it's you have more chance to forget this kind of topics. So keep revising the same session you will find on YouTube, and it's completely free. Just go there and revise this, as well as we'll see some questions based on this, the whole chapter. We'll see all the questions based on that. There is one topic left in this chapter, that is rounding of the numbers, which is very basic basically, but we'll see in the next session how to round off the given numbers. Till then, just keep practicing. Thank you.